Hey Simone, what's up?
Hey Benedetto, everything all right over here? What's up over there?
All good, all good. So,
Nice.
these lambdas, we are going to talk about lambdas and some distributed computing in general. Our
Uh-huh.
audience is supposed to be executives and decision makers, so we'll try to not go too much into technical details.
Uh-huh.
And also, we engineers, we are used to think about performance and architecture, but who needs to decide which technology to buy or to choose, right? They also operate on other dimensions like risk, is it maintainable or not, long-term effects, and talent and those kind of things. So we'll talk a lot about this, but in 45 seconds, what are lambdas for executives?
It's difficult, right? But the way I like to explain Lambda is that they are an abstract computing platform, right? So you provide Lambda usually refer to AWS services, but the major cloud provider is something similar. And you just provide the code. You don't care about all the infrastructure behind, right? Up to a level, of course. So you don't care about upgrading operating system. You don't care about much. You don't care as much as you would care on premises on security or all these kind of things. And they will provide a rather good fit for a lot of workload. So yeah, flexible computing platform. That's
Okay,
very high level.
that's a perfect start. So let's try to go to list use cases that we find in general in distributed computing, and let's try to see which ones are good for lambdas, which ones are not, and what else might be, useful. So let's suppose we have a website with some backend services. How and when we could use lambdas in such system?
There are a lot of consideration to do, right? So if you have very small traffic, very little traffic, and these lambdas and functional service usually suffer a bit from this problem of cold start. And you may not want to use them if you have very little service or 1 or 2 calls every minute. However, on the other hand, if you have a lot of requests, this problem kind of disappear in the background. So that's a good fit. And then they work super well for event driven workload. So you get a request through whatever reason, and then Lambda compute and either come back with something or give you change a database or yeah, for this kind of things they work really well.
Okay, so let me try to put this in perspective. So you said if you have a service with very little traffic, lambda might not be a good fit. So can we try approximately to define what's low traffic or too low traffic? Just to have
But
an
again,
idea.
let me be clear, right? This depends also on your expectation, right? So if you want something that respond, you don't care too much about latency, you maybe by this phenomenon core start, you'll be fine with Lambda as well, right? While if you really care about having a super snappy service, maybe Lambdas is not perfect. And even there, right? If you there are ways around it. There is a lot of way you can architect even for low traffic, but then the cost is going to be another part of this equation. And for low service, I would say if you have 100 user, 1,000 user, less than that is, I would say, low.
Okay. So I wanted to jump into cost, but I think I want to keep that for the for last. You mentioned event-driven application or scenarios. So are we talking here about orchestration when you have complex services distributed on or you are talking about or maybe, what do you mean by event-driven?
So Lambda can be used in a lot of different way. Again, it's my original description is a computing platform, right? So you can use it in a lot of different ways for do a lot of different things. And it could definitely be used as orchestration, so something that listen or wait for some signal and does something, but can also be used on what we usually call data plane, right? So where there's an intense amount of data and traffic going through them, right? So yeah, to answer your question, both of them in this case, right? So if you're just something that you need to wait for one signal that happens once a day, once every hour, Lambda are perfect, right? So you just listen to what will be a queue in AWS, something that changed in S3, and you have your little Lambda over there that detects the change and does whatever custom logic. And that's perfect. It's super cost effective. It costs nothing. And you don't need to think about maintenance. You don't need to think about security. You don't need to think all these things that are hard, and AWS or the cloud provider things for you. And on the other hand, you can also do like for data plane, right? So you have a lot of requests, or for instance, you're doing the example that I always get in my mind is if you are like Ticketmaster, right? A big provider that send they have a lot of users that make a lot of requests, right? So you have one ticket, two ticket, three ticket, all to allocate, and you can push all of them to Lambdas. In previous experience, we used that for metering of manufacturing data, right? So we had a machine that were sending a lot of data to Lambda, and that was working as well. So it was a message, so on and so forth, and Lambda was taking care of getting all this data together and do the action that in that case was just storing. But yeah, did I answer?
Excellent. So you're saying lambdas are good both for the control plane and the data plane. Now let's talk about compute. Data computing. So data processing. So are lambdas good for data processing, or when are they good?
Like batch processing and stuff.
Yeah. Also.
I mean, you could, even though there are more cost-effective ways, right? So usually you'll be able to spin up instances that are much beefier, much bigger, and much cheaper than using Lambda. So it is possible, and in some cases it may make sense, but batch processing or just analyze a big file and figure out what is wrong with them, or aggregation of data, I would suggest different services.
Yeah, like possibly things like Spark or big data. I was kind of fishing. I was tempting you to give. So let's say the lambdas are good for controlled, maybe small or short actions that are repeated. Even at scale, they work well. They can be cost effective. We'll go back to that. But so what languages can I use to write lambdas? Almost everything?
Almost everything. We are almost, right? So there are mostly two ways of lambdas. One, there is a set of language. Here I'm talking about AWS, which is the service they know best, right? But there's a set of languages that AWS support, mostly Java, Python, and Node. For this service, you can just upload your zip file with the source code, and then it will do everything for you. If this is not enough, if those languages are not enough, and you want to write your Lambda in very esoteric languages, or if you have a complex deployment, Lambda allow you to provide a container, like a Docker container, and that will take care of, and Lambda itself, the platform, will take care to invoke it with recorded data and everything. Of course, you need a bit of setting, a little management of how you start the application, but you can use pretty much any language.
Earlier, you mentioned about using lambdas to be triggered by S3 events or other maybe DynamoDB events. I suppose that's very easy and straightforward to use them as to have them triggered by other AWS services.
Yes, it's usually just a click in the console of Lambda, so it's usually extremely simple. And there is all a world of infrastructure as a service, so this allows all engineers to set up the infrastructure as code so they can be replicated in different regions, different settings very, very easily. But even for prototyping, usually just a click in the console. So it's super, super simple.
So what about other features and functionalities that are needed when you are in production, like monitoring, logging, troubleshooting? I have to say that I don't want to speak bad about Lambdas, but we were among the first users of Lambdas 10 years ago, 11 years, I don't remember. It was a long time ago. Lambda had just came out 4 or 5 months before that?
So it must have been 10 years ago, because recently Lambda celebrated its 10th birthday. So like in these days, celebrating its 10th birthday.
It makes sense. I was in a, let's say, in a big travel company in the lodging analytics, and I don't even remember where we used Lambdas for what, but they were so. The process that was running the Lambda, actually, probably the entire VM, was going down at exactly 300 seconds after the start, with no logging and no exception. Just vanishes. The process vanishes, and so yeah. The question is in general, monitoring, logging, debugging, etc. And how do you handle the shutdown right now?
Okay, so at the very beginning, I believe Lambda was short-lived. 300 seconds kind of sound right. Right now it's 15 minutes. So you can keep the same Lambda running for up to 15 minutes. After that, it goes into timeout, which again, for some applications, okay, for some others, a little less okay, for instance, batch processing. However, if you want to go back to monitoring logging, they're doing a lot of progress, a lot. And you have a whole set of metrics that show you how often Lambda is called, how much cost, and all the kind of cost, why it costs so much or so little. And they're doing a lot of progress in this set of metrics. They're just providing metrics. At the same time, there are a lot of progress also on logging and just having the logs. So there are integration with, okay, of course, CloudWatch in AWS, but also with the external provider, right? So if you have already your own monitoring infrastructure in, let's say, Datalog, and there is the possibility to just push your log from Lambda to, say, Datalog or whatever else you're using. So yeah, I would say that the monitoring and everything is really in a really good shape, specifically also given the complexity of the product.
Yeah, okay. I never used Lambdas at scale, but I imagine that if you were mentioning, a ticketing system earlier, but if you have events, I don't know, millions of events per day, and each event triggers, a few Lambdas, that's, can you generate custom metrics? How do you measure the performance when you have something at scale?
Yes. So it's complicated, right? Because complicated is whenever it's a scale, you add another dimension of the problem.
Let me interrupt you a moment. Okay, so
Sure.
when I ask you a question like that, and you say it's complicated, the audience, the executive in the audience that is listening, say, okay, so I need a very senior developer here. I cannot have a junior dev using Lambdas. Is that a fair assumption?
No,
At
not
scale.
really. But depends on the scale that you get, and up to some scales, you want somebody that knows what he's doing, right? And that's always whatever platform computer you're using, yes, right? So it's not Lambda, it's not a CTO, it's not whatever. Once you cross some threshold, that depends on the business, you want somebody that really knows what he's doing, managing the infrastructure one way or another. And but for monitoring, for instance, even at scale, usually the way I interact with Lambda monitoring is beside the monitoring already provided by Lambda, that usually is only referring not to the business logic, but is referred to how long the Lambda is running, how many Lambdas are running at the same time, etc., etc. So beside that, the way we usually do is to integrate with the CloudWatch. Again, I'm inside AWS ecosystem, right? So it is definitely possible to create a publish metric from a Lambda to CloudWatch or to other system, right? So if you have your custom metrics or your custom metric, you can just integrate that with push to Datalog, CloudWatch, whatever system you're using. That works really well as well.
Can we say that if you run Lambdas, you have for free in AWS, some kind of, let's call them system level metrics, where you see how many ran, time, cost, but if you want some business level KPIs, so how many Lambdas ran for my ticketing system, in Italy or in UK or in Belgium, or you want other kind of data, you can easily generate metrics from inside the Lambdas, push them
That's correct.
to CloudWatch or to whatever you want, and then measure them.
That's
Okay.
correct. That's correct.
So you mentioned EC2, right? So let's try to give a basic idea to what's EC2, what is an EC2 box or VM, what is. So we have a physical computer, right? I'm running on a physical box right now, 32 cores, 256 gigs of RAM, and I'm very happy about that, right? So that's a physical machine. An EC2 instance, can we say that is a VM in AWS somewhere, right?
That's correct. Yeah.
That's correct. Now, VM in a physical machine with other tenants, or maybe only VMs from my company or my own tenant. Can we?
So, yeah, we can clarify, right? So, first of all, EC2 usually come in two main flavors, and EC2 and the Metal instance. So, Metal instance is literally physical bots, and you don't get a real hypervisor, or better. On top of the Metal instance, you can run your own hypervisor for doing whatever business you want. This is usually, I expect this to be used by other provider, cloud service provider, not really people that use EC2 for building business, but people that use EC2 Metal for building infrastructure for other business. And that is a possibility. Those usually are very big boxes and come out with a big price tag because they are huge boxes. And then this virtual machine are sliced in this big EC2 bots are sliced into using virtual system into virtual machines. And each one, then you have this different flavor and different size, right? So you can have, we can check the EC2 pages, but they have a lot of instances, a lot of different flavors, each with different costs and different networking, different EBS like I/O and performance characteristics. So they do run in physically. I believe they run. I believe because I don't have inside information about them. I believe that you can share the same physical bots, the same big machine with other customer, but there is a lot of attention to a workload completely separated, right? So there's a lot of layer of separation between you and another customer that may run on the same physical EC2 machine.
So we go, and you can run everything, right? In either flavor of EC2, you can run your applications, compile for Linux or Windows or whatever you want.
Of course, you need you will set up the correct operating system, the correct infrastructure, but you can run. It's your machine. You can do whatever.
Yeah, you own it. Now, a Lambda, can we say in simple terms that it's like if you write a function of code in one of those given languages, and it just runs, right? It gets injected with an environment, but you don't know where it runs. You have at your disposal a quantity of memory, number of cores. Can you choose memory and cores when you run a Lambda?
What you choose is the size of the Lambda, right? So the more memory you give to the Lambda, the more core we'll have, right? And roughly, when you get a Lambda of roughly 2 giga, 1.8 giga, you get one full core. And then if you get more, you get proportionally more, proportionally less. And yes, but one big selling point is that you don't really care about all the stuff that are underneath. You don't really care about the operating system that you need to install. You don't really care about all the security patches. You don't really care about all the stuff, right? So you just have this that does your business logic, which is usually what people want from a computing platform, right? They don't want to care about the operating system they're running, right? They want to make sure that the function, the business logic is running, is working.
Yeah, especially when you do experiments of proof of concepts. Much of my career has been around that, and it's very convenient to have something that you can spin up and run, and don't care about other. You validate the functionality, and then maybe if it's too expensive or too slow, you can choose other methods. But running a Lambda is like, yeah, sure, let's use a Lambda. We should say, Simone, that you are here in your personal capacity, right? You do not represent AWS or Amazon. Your ideas are your own.
Yes,
and you are not revealing anything confidential, right? It's just
absolutely not. Everything I say can be found in AWS documentation. Is common knowledge.
Yeah, I mean, we won't say. I mean, it's common knowledge, but the experience that you acquire after years of running and software in a distributed environment is important, right? It's not something that when I talk to younger people, I say, what's the difference about distributed computing? Is that if you want to study a new language, you want to learn Java or C++ or Rust, you download a compiler and start playing in your computer, right?
Right.
But if you want to play with a cluster, either a cluster of your own software or a Spark cluster to do big data computing, how can you do that? You need tens or hundreds. And what happens when you have hundreds of computers? It doesn't happen when you have 4 servers, with a cable and the switch. It's very different. And for that, I don't think that the new generations are prepared in new university or colleges. It's a different world.
Yes, it's a difficult subject in general, but the interesting part about distributed system is that they give you much they're supposed to give you if they are designed correctly, and more than what you pay for them, right? So the fact that you are running a distributed system it buys you a lot of security, right? So you can say, okay, if this instance goes down, if this data center goes down, my business keeps running. Sometimes this is a necessity, sometimes may not, but yeah. And I see lately younger generation, it's happened that I'm close to academic as well, and there are some attention to this topic as well, fortunately, lately, right? So it's, lately there is some attention to this topic as well, and yeah, it's getting a little better.
Yeah, I remember the first time that, because my first half of my career was on single box, right? I was in the Microsoft C++ compiler and everything single box. And then when I joined an organization where we had like more than 1,000 servers in on-premise running a C++ legacy code. I mean,
it's a different problem, right?
It was a plus. Yeah, it was. So when there was a bug, and I said, let's attach a debugger. And they laughed at me because they said, first, this bug happened, I don't know, 3 days ago on 5 or 6 of the 1,000 computers that were in production. We as developers, we cannot touch them. We cannot ping them. They are in an area, far away from our credentials. And I said, okay, give me some logs, and I will. And so let's go back to. So we said Lambdas are good for event-driven orchestrations, single actions that are repeated. A lot, even at scale, they go well. They can be attached, they can be triggered by AWS events. I mean, we are talking about AWS and Lambdas, but I bet that if you go to Azure and their functions is probably the same. Actually, I know it is, but so I think with AWS, you guys came first, right? Or they came first. So the names stuck. When I need to talk about distributed storage, I call it S3, even if we are working with a client on Azure, and I say to the developer, say, okay, when I say S3, I mean the Azure Blob Storage, but S3 is shorter, and has been printed in my mind for the last 15 years, and same with Lambda. So now, if you need to compute a lot of data, if you have data coming in and you need to do a lot of computation, maybe Lambdas, is good for small cases, but in general, if you need to work on big data or a lot of data, you might want to use Spark, you might want to use Flink, you might want to use, Kinesis. There are other things to move data, and, Kafka.
There's a lot of solutions.
There are a lot of solutions. Also, you have batch solutions, you have streaming solutions. So we probably can spend an entire episode or maybe 3 about that. I don't know. Is this something that you are familiar with? Have you worked with batch or streaming solutions?
Not too much, not too much. Currently, we are working with in some capacity in batch, so like
Okay.
having a lot of data and doing some internal work on the mostly aggregation. And for a solution like this, it seems very cost effective to use just S3 and computing, right?
Yeah.
So the solution that we picked was S3 and ACS, which ACS is one of the container solutions provided by AWS, right? So
Yeah. And I want to talk about that because actually we started and then we got derailed. It's my fault. We talked about, physical machines, bare metal, VMs, lambdas. Now, are you familiar with Docker and other form of containerization, Kubernetes?
not so much with Kubernetes. I mean, I'm familiar as in I touched all the topic. Then there is familiar as in I actually work on it in a production environment, right? In this case, I'm more familiar as in I just know what they are.
Okay, let's try to explain this to, our audience at the end, they are dumb executives, right? So we should, we don't need the creator of Kubernetes to explain to them what it is.
Right. So at the beginning, container were a solution, product that was existing before Docker, right? Before Docker, there was this LHC that was doing roughly the same, but the big revolution was with Docker and the idea of Docker file. So what is this Docker file? It's a recipe of how you create the application that you're running, right? You are interested in one application and there are some business logic, so you put all the code into Docker using a Docker file, and you get out what is eventually just a tar file that you can deploy in different machines, and that it will just run, right? And
it will run even if I want, if I want on this machine, I want my web server, or maybe I want three web servers, a load balancer, a backend, 2 backends, a database. I can just put everything in one recipe.
Well, you could, but the usual solution is for web server having their own Docker, and in the database you need to consider the storage layer, which with this technology with containers requires some attention. And so what you usually do is to split all these component responsibility into different containers. You could have a single one doing all of that, but is not the standard way to do it.
Is that possible in Kubernetes to deploy an entire fleet of, stuff?
Exactly. So after containers, after Docker getting old in the industry, there was another problem as how do we orchestrate all these containers together, right? So there were people actually deployed by hand, one container for the web server, one other for the load balance, etc., but it gets really messy really fast, right? So the solution, this come out of Google, is the software called Kubernetes, and it's abstract a bit the concept that you can find a standard software application, right? So it's abstract the computing layer, it's abstract the storage layer, it's abstract the ingress layer into common terms, and then you implement a container for each one of those. And then the Kubernetes, the orchestrator Kubernetes takes care of automatically adding capacity, removing capacity, spin up new version, spin down old version, all these kind of things that otherwise you will need a team of people to follow up with. So roughly, this is the idea behind Kubernetes.
I told you I wanted to go back to cost because cost in AWS, can I say that it can be painful? I will share with you an anecdote. So I was in this lodging analytics group of this big travel company. It was about 10 years ago. And then they used to do analytics. There were this bunch of, a lot of product guys that were running their models, right, on the behavior of the people on the websites, on prices with the compare. There were a lot of models, and they were using Hadoop. Do you remember Hadoop?
I remember Hadoop.
So
yes.
it was supposed to save, right? To save the world from.
It was big data. It was the solution to big data.
Yeah,
yes.
and we had I don't know how many servers and hundreds, thousand, I don't know, and so so the first thing is that so we had booking data, right? Let's say about 1 million bookings a day. And you know how many copies of the booking data, we're talking about 2 or 3 years, there were after 2 or 3 years of using Hadoop?
No.
Shoot a number. There were a little bit shy of 3,000 copies.
Okay.
Of 1 million booking per day per, I don't know, 1,000 days. So let's say 1 billion. And they said, oh, we need to do, this processing. I don't remember. I think I had to do some, like a SQL query of a table joined with itself and some other thing. So it was a relatively complex query on a few terabytes of data. And they said, okay, let's, they told me, they gave me the mandate. We need to go faster because now we start the compute, we go take a coffee, we come back, it takes an hour. Okay. So I use Redshift. Okay. Redshift is a data warehouse, columnar, SQL storage, a very convenient service provided by Amazon. You can choose the number of servers, so they cache the data. It's very fast. And so I put there a bunch of servers. And I did this, imported the data, I ran the queries, and it took about 7 or 8 seconds. And I still remember the product lady was looking at that, drooling, I want that. And so I made that available to them, right? So after 1 month, the bill came, $40,000. You are spending $40,000. I said, first, you didn't give me a budget. Okay, you give an objective to a tech guy, to an engineer to go faster. I go faster. What do you want? The revenue is 7 billion a year. Lodging was 70% of that, roughly 5 billion a year.
Right.
I give these guys from 1 hour to 10 seconds, and you complain. Anyway, so we went back and they say, okay, we cannot spend 40K a month, so we did a Spark job cluster to process the data and spend maybe, I don't know, 3-4K a month or 5. But we ended up using 400 servers for a Spark cluster with 400 nodes, compute nodes, and that was... Anyway, my point is, in the cloud... it's not just in AWS. In the cloud, it's easy to spend money, right? Because I want this, click. Oh, it goes faster. Maybe you get the bill once a month, or or even if you monitor your costs at the end of the day, it can be substantial because when you spin up, even my Spark cluster, you spin up 400 nodes to do your compute. It's not free, right? It does have a cost. So Lambda cost in the various scenarios that we mentioned, cost monitoring. So what do you think?
Lambda cost. So if you go look into the cost for gigabyte minute, gigabyte second, actually, Lambda will be one of the most expensive products you can find, right? So for gigabytes for second, it's going to be one of the most expensive products. However, what's happening in Lambda is that AWS meters that by millisecond, right? So they meter for you only the times in which your Lambda is actually running and doing work. Only the time that your Lambda is running. This is a big difference from on-premises model or EC2, where you buy by the hour. And even if your CPU is doing nothing, you are still billed, right? So
sorry, a clarifying question. When you say do nothing, it means that, so if my Lambda does an HTTP call to another service, to DynamoDB to get some, or to S3 to get some data, and it's idle for, half a second.
No, you are still billed for that half a second while you're waiting for network.
Okay.
Yes. When you're waiting for network in AWS Lambda, you're paying for it.
Okay.
Well. I mean,
So
And
I tried.
well, the good news is that you could make multiple requests in parallel, right? So there's, of course, there's a lot of way to optimize I/O idle, but in the Lambda, as long as your function is running, you pay for it. So yes, the big difference is what you're billed for. So in platform like Lambda, you bill by the millisecond, while in other platform on premises, you're billed by the hour or
So the time chunk is the
chunk.
millisecond. So if you run for 2 minutes, you pay for 2 minutes. In EC2 probably is by the hour or by, I don't know.
I believe EC2 is by the hour, but I could be wrong.
And anyway, it's not a millisecond.
It's definitely not millisecond. But the big difference here is that whoever is doing this calculation, usually the smart thing to do would be a lot of different factors that goes into if you open up your EC2 instance and you go look how much they're working, what is the CPU load, what is the memory load, and it's very, very rare that you see an instance 50% busy or 80% busy. They're usually 3, 4, 20% busy, right? So,
but that also on purpose, right? Because I remember in my days, you don't want your EC2 instance to be 80%, because if you have a traffic spike, if more people are clicking on your website because you did an advertising somewhere, you will. I mean, you might have some elastic behavior, but usually,
of course, there is a lot of consideration to do in how busy, how hot you run your services.
But for Lambda, you just run when you need it, and so you pay. So, what about what you were saying at scale? When you run at scale, millions of instances per day. At that point, the cost becomes comparable or even greater than an EC2 machine, or multiple machines.
Again, it depends what you are comparing to, right? So one big comparison is how can you run, let's say, even 1,000 EC2 machine, right? The question that I see asking a lot is, do you have the internal capabilities of having this much computing power, to handle this much computing power? How you will patch or update the operating system of 1,000 machine, right? This is a question that, maybe it costs 20% less, but then I don't know how to patch them, right? Or do you monitor all of them, right? So serverless platform removes this problem for you. And but if you just look at the cost, depends how much you can, how hot you can run this machine. So if this machine run 2% of CPU, Lambda is going to be cheaper. If you're able to run this machine 80%, this machine are going to be cheaper, right? So there depends a little about how well are the operation for the people running the workload.
Maybe let me try to offer my point of view. I would say that even if you have something at scale, if you're a small company or a medium company, I would say start with a Lambda. Even if you are a big company and you have money, start with Lambdas. Make sure it works because it's easy. Boom, as you say, you don't have to patch, you don't have to coordinate, monitor, debug, VMs or many of them. And then when it's stable and you are, you go live, start making money with your service or whatever, and then if you have the capacity, if you have the time, if you have the skills, and if the will, you could do a budget exercise. You see, how much you spend with Lambdas, or you can project that. Maybe you have only 100 clients, you can project that what will be with 1,000 or with 1,000,000. And then you can try to infer or to estimate how much you will spend with EC2 VMs. And then, you might want to go over. But, crossing the bridge, as you said, might save you some money. But even if it does, it will create more complexity in your organization. So you need to ask yourself whether that is worth.
And in many cases, there is also a big opportunity cost, right? So all this process to move in from one computing platform to another, from Lambda to EC2, to Lambda, to EC2 to AKS, whatever, it does not come from free, right? So there is a lot of effort to try to make the stuff, all this migration, as simple as painless as possible. However, they still require engineers. They still require time. So whoever makes this decision should balance whatever money they're saving or the project is saving against what those engineers could be doing in the meantime, right? So because 2 months of engineering time is a lot of time. Like a lot of feature can be added and a lot of new stream of revenue can be open. So yeah, of course.
Yeah, they need to consider that. So one clarifying question, Simone, about your, you said earlier about that lambdas are charged gigabytes per second. So what is that? You know, I/O. I mean, what kind of metric is that?
It's how big is your lambda? So how much memory is available to your lambda? So if you have a lambda that needs 2 gig of memory and they run for 3 seconds, they will charge 2 by 3 for whatever is the cost of the lambda. And this is something that you decide up front. So the engineers, they say, okay, this lambda is very small, it's not doing much, it needs half a gig of memory, right? And then you set up the setting and says, okay, this lambda needs this much. And so you will know that for how long this lambda run, we charge that amount of millisecond, second times how much memory they are associated with.
So, so that means that if I need, so a number of cores grow with memory. So it means if I have a use case where I need a lot of cores and very little memory, it might not be
ideal.
My best, choice.
You usually have the opposite. So you may need. Usually we see a lot of. My experience is usually the opposite. So the problem is usually.
I agree.
I need a lot of memory. I can do with little core, but yeah. So
I agree with you.
Yeah.
I was trying to find a real example for this hypothetical scenario, but so I want to explain all the dimensions, right? And that sounded to me something that is not the ideal case. But then when I think about the real use case, it doesn't come to my mind right now. So anyway, that's fine. So. Okay, I think that we explored a lot of Lambda. What's the future for Lambdas? What you can say? Or what you would do if you were the boss, the Lambda boss?
I think Lambda is doing an amazing job. They keep adding feature and keeping support to languages coming as fast as possible, right? And I see Lambda as a fundamental computing infrastructure. For personally, I see Lambda. I think a lot of people share this opinion, but a fundamental computing infrastructure for all the major cloud providers. So I believe they will be very, very stable, very, very something that business can rely on, right? So what the future, I don't know.
Talking about computing platforms, let's see if you guessed this one, where you can store data, you can do a little bit of computations, you have queues, you have sorted sets, you have hashes.
You talk about Redis for sure.
Redis, and Valky now, right? Did you follow the?
I didn't follow too much, understanding that there is a change in license. So there was this fork of Redis in Valky, I don't know how to say.
Valky, Kival, right? Kival store, Kival, Valky. And Amazon also is a pusher in this direction. I
think it is. I think it is. And Amazon itself has an internal offering as an elastic cache. So if a business need Redis provided, definitely elastic cache is a possible solution.
Actually, by the time that this podcast will go out, hopefully, I will have attended a Valky event in Las Vegas next, at the same time of reInvent, but it's not part of reInvent. And I will actually also speak for a few minutes, for 10 minutes, a flash talk about Memurai and that sort of thing. And so yeah, we are kind of both experts in the Redis ecosystem, and we are kind of competitors, right?
We used to, but
We used to, at least, or at least we try to be.
yeah.
So yeah, both of us. I don't know, Redis. People, if you join for Lambda and that stuff, probably we are done. We now are chatting about other technologies and fun stuff. So Redis is an amazing tool. It's not only a cache, it's only a message bus, and that would be enough, right? It's a small computing, because you can do some computations, like you have variables on your computer. Instead, you have these data structures in this distributed system, which is amazing. And hashes in particular are data structures where you have a main key and then a lot of fields, key value, key value, key value. So you might have an ID for a product, and then name, date, full description, price, etc. And there was a problem called secondary indexing. So if you need to search for fields, give me all the products where the price is $25. You could not do that with Redis natively. So people would create indices, by hand with all the secondary values. And Redis, the company, the software, I don't know, so they came out with this Redis search module that you could attach and load into Redis, where you could create indices and search them. But for some reason, they use this ugly, weird syntax, which, and Simone and myself had this idea: why don't we just use SQL? I mean, everybody knows SQL, even our executive. Oh yes. And so independently we came out with this stuff, and we did that in slightly different ways. But you actually sold a few of them, right? Or someone was using yours?
There's still a customer using what used to call Redis SQL, now it's called Z-SQL. And there's still some people here and there using it. And the product is rather simple, right? It's, as you say, a Redis extension, and it was using SQLite underneath, right? So it will give you all the power of SQLite to manage data, being as fast as Redis and being in every environment where Redis is currently running, which was a total selling point, and mostly will be able for small application to replace big bulky databases, right? So the idea behind Redis SQL was, okay, since I need Redis anyway, why also need a database? So databases tend to be rather expensive to run, rather difficult to operate, difficult to upgrade.
Correct.
While something like Redis, it can stay there. And I mean, there are story of old version of Redis stay there up and running for 10 years, right? That is more than any business will care if you want. So the idea was, okay, give me a Redis instance and I give you a SQL database good enough for most use cases. And it was a fun project and with some use.
Good. And by the way, a big ciao and kudos to Salvatore Sanfilippo, Antilles, creator of Redis, our idol. And my motivation was quite similar. I tried instead to keep the data inside, so I'm not using SQL, or rather, I created a database engine where the data is stored in memory outside Redis. The product is called Memorize SQL because it's a SQL extension to Memorize. Memorize is Redis Enterprise grade for Windows, with proprietary and code owned by Genea Systems. And also Memorize SQL, although I wrote it, is owned by Genea Systems, which came open source last June, by the way. And so I put all the data, I have the indices, and what I try to do is something that runs decently fast but does not block Redis. So you can run a lot of queries concurrently. You can ingest data while queries are running without disturbing the queries in a somewhat fast way, although I think I kind of remember that yours was faster, or for some kind of traffic or number of queries was faster. I don't know. Maybe mine could run 20 queries at the same time with decent speed, and yours could run very fast, one query at a time. Is that possible?
I was focusing on getting data in and out as fast as possible,
Yeah.
instead of concurrency, because SQLite is not as great as write concurrency, right? So
Yeah.
you play your strength.
Yeah. And so, but we were a small company, and there was no a lot of marketing push, and I don't know if anybody's using that right now. Anyway, good times. I think that I would love to talk about Redis with you, and Redis is huge, and yeah, I consider it almost like it's not a complete computing platform, right? You cannot do everything.
Right.
But almost you can run Lua script, but they block the server because Redis is single threaded and everything. So yeah, but it would be nice to talk about that one day.
Of course.
Okay, man. Thank you for your time, and
Thank you.
we didn't talk about you at the beginning. So why don't we say that you give us a few words about yourself and what you do, where you do it.
I'm currently in Dublin, working for AWS in CloudWatch. So yes, we are, yeah. And I was I had experience as well in Lambda, working still in Dublin for AWS for Lambda, and then I'm currently in CloudWatch.
Excellent. Well, you have a lot of experience. You have done a lot of good things. You are very humble. So I will say something now that I've not told you before. So if you want, I can edit it out. Okay.
All right. Let's see what you see.
So you are a great engineer. You can drive a product to completion. People are using your product. You are in in one of the big five, and you are successful. You know how to communicate. You are good with people. Again, people are using your software, right? So you know business. You understand business. In the long run, I see you as an executive, as a product people, as a business guy. Have you ever considered that? I mean, do you like business? Do you like managing people? It's not exactly the same, right? Because you could be in the business as an IC, or you could be a VP, and have 1,000 people reporting to you. Are you considering that career?
Never seriously, right? So always been an engineer at heart, as in a fixing problem. However, lately, especially in big organizations, you notice that the difficult problems stop to be a coding problem and strictly
Yes.
engineering problem. They start to be organization problem, communication problem, team creation problem, etc., right? And I must say that it starts to be a little more fascinating, fits in those kind of problems instead of strictly technical problem. So we'll see. No, I'm taking stuff slowly right now because my personal life, personal situation is changing a bit. So one step at a time.
Well, but I'm glad you noticed that. So you are already in that path. If you are fascinated, I used to consider that the dark side of the business, and suddenly after many years, yeah, there are some problems that do not require being alone in a dark room, and those problems, for those kind of problems, you need people that understand the technology very well, and understand people. People have different motivations, different histories. We need to be able to communicate with everybody, and and then you need to understand the business, what brings money, what brings risks, what brings maintenance problems. And you mentioned all of that. You are very aware when we were talking about lambdas and stuff. So that's why I told you that. Do you mind if we keep this part?
And if you want to, I don't particularly mind.
Okay, Simone, thank you very much for your time. And
No, thank you.
I'll see you soon.
Of course. Have a good day.
Bye. Ciao.
Bye bye.